Let us solve OpenStax University Physics, Volume 1, Chapter 5, Problem 23. Andrea and Jennifer push a couch across a floor. Andrea applies 130 newtons due north. Jennifer applies 175 newtons at 28 degrees east of north. East is positive x, and north is positive y. We need the sum of the two forces in component form, then its magnitude and direction. Finally, David and Stephanie must supply a combined force that makes the total force 0, so the couch does not move. Start with the directions named in the problem. Draw east horizontally and north vertically. Andrea's force lies exactly on the north axis. Jennifer's force points east of north, so it tilts to the right from the north axis by 28 degrees. The drawing need not be exact, but make the 175 Newton arrow visibly longer than the 130 Newton arrow. A reasonable sketch helps us anticipate a resultant that points mostly north with a smaller east component. Jennifer's angled vector contains horizontal and vertical components. Draw the components head to tail to make a right triangle. The given angle is measured from vertical. Moving that angle to the top of the triangle gives the same 28 degrees because the vertical lines are parallel. Now, read the triangle with SOHCAHTOA. Relative to the 28-degree angle, the x component is opposite, so sine gives fjx over fj. The y component is adjacent, so cosine gives fjy over fj. The drawn triangle, not a memorized pattern, select sine and cosine. Andrea's force is easy. It has 0 x component and a positive 130 Newton y component. Jennifer's x component is 175 sine 28 degrees, which is 82.16 newtons. Jennifer's y component is 175 cosine 28 degrees, or 154.5 newtons. Both components are positive because her force points east and north. Unit vector notation keeps each direction attached to its coefficient and lets us use ordinary algebra. Now add x components to x components and y components to y components. The x total is 0 plus 82.16. The y total is 130 plus 154.5, giving 284.5 newtons. Therefore, the net force is 82.16 x hat plus 284.5 y hat newtons. This agrees with the sketch. Both components are positive, and the much larger north component makes the resultant point mostly north. The resultant components form another right triangle. Its magnitude is the hypotenuse, so the Pythagorean theorem gives the square root of 82.16 squared plus 284.5 squared. The magnitude is 296.1 newtons. The requested direction is measured from east toward north. Tangent is rise over run, so tangent theta equals the y component divided by the x component. Inverse tangent gives 73.89 degrees north of east. Both components are positive, so this first quadrant angle matches the diagram. For the couch not to move, the total force must be 0. David and Stephanie therefore need the equilibrate, a force with the same magnitude as the resultant, but the exact opposite direction. The cleanest way to find it is to negate every component of the net force. Thus, their combined force is negative 82.16 x hat minus 284.5 y hat newtons. Adding it to the first two pushes gives 0 in both components, which directly checks the answer. The two applied forces add to 82.16 x hat plus 284.5 y hat newtons. That resultant has magnitude 296.1 newtons and points 73.89 degrees north of east. To balance it, David and Stephanie apply the negative of both components. The reusable strategy is choose axes, draw the right triangles, resolve each vector, add like components, rebuild magnitude and direction, and negate the resultant when equilibrium is required.